Here is the definitive strategy to stabilize your entire release cycle. It does not matter how sophisticated your test automation framework is. If your environments are shared, static, or polluted with dirty state, your test will be flaky. Fixing flaky tests requires fixing the infrastructure first. The first tier is the local and pre-merge environment. The rule here is absolute isolation. Developers should never connect local builds to a shared staging database. Instead, utilize Docker Compose and Testcontainers to spin up ephemeral, fully isolated data stores. Here is a concrete step-by-step implementation of this workflow on the pull request level. Step 1. A developer opens a PR. This triggers a GitHub Actions workflow that executes a Helm chart to provision a dedicated ephemeral namespace inside your transient Kubernetes cluster. Step 2. Dependency isolation. The pipeline leverages test containers to spin up a fresh Postgres Locker image specifically inside that namespace. Simultaneously, it deploys a WireMock container configured to stop all third-party external calls. Step 3. Execution. Your automated test suite executes strictly against the isolated endpoints of this temporary namespace. Step 4. Teardown. Regardless of whether the test suite passes or fails, the final step utilizes Helm to completely destroy the namespace, freeing up compute resources and leaving zero state behind. The next tier is the system and staging environment. This must be a one-to-one replica of production. The primary cause of instability here is state pollution. You must leverage APIs to generate unique data payloads on the fly for every single test execution, ensuring zero data overlap. Finally, we must implement a strict observability stack to collect, categorize, and triage environment instability. Deploy a unified observability mesh using OpenTelemetry. Aggregate metrics with Prometheus and collect distributed traces and logs using Prometheus and Flaky. When instability occurs, you cannot just look at Grafana dashboards. You must categorize the data. You need to know instantly if a failure is an infrastructure issue, like an out-of-memory kill, a data state issue, a network timeout, or a true code regression. But here is the critical architectural secret. How do you link a backend microservice crash to the exact automated test that caused it? The answer is distributed tracing and header propagation. Your test automation framework must generate a unique correlation ID for every single test scenario. You must inject this ID as an HTTP header like w3c trace parent or a custom x-correlation-id into every single request your test makes. This header must propagate through your ingress controller and down to every downstream microservice. Furthermore, your test runner logs must be shipped to the exact same log database as your backend logs. This creates a unified, queryable timeline of events. To triage this efficiently, we eliminate manual log digging and introduce AI. When Prometheus Alert Manager detects an environment anomaly, it triggers a webhook. We route that payload, along with the aggregated stack traces, directly into an automated log analysis agent. Because we implemented correlation IDs, this specialized LLM does not just see a random 500 error. It instantly pulls the exact test steps that were executing alongside the backend stack trace. It maps the error across your service topology, automatically categorizes the instability, identifies the root cause, and determines which microservice is responsible. It then posts a complete root cause analysis to Slack, tagging the exact engineering squad required to fix it. This reduces mean time to resolution from hours down to seconds. To summarize, stop sharing databases. Use ephemeral Kubernetes namespaces on the PR level. Heavily virtualize your dependencies, inject correlation IDs into your tests, and replace manual triage with OpenTelemetry and AI-driven log analysis. Thank you for watching. If you found this breakdown valuable, please subscribe to the channel and leave a like. See you in the next pipeline execution.